All right, so in this particular problem, we're trying to find the length of the plane curve. In this case, we're trying to find the surface generated by revolving the given, well, let's say it's curve about the x-axis. So we have this, we have y is equal to square root of 25 minus x squared, and we're going from -2 to +3. So the very first thing we need to do is we need to take the derivative, correct? So, and I can rewrite this as 25 minus x squared raised to the 1/2. Okay. So when I take the derivative of this, we get y prime, and the 1/2 goes in the front. We get 25 minus x squared, and then 1/2 minus 2 over 2 will give us -1/2. Then we have to think about the chain rule. Okay. So that's going to give us times that by -2x. Okay. All right. Now we can simplify this, and the 2's are going to cancel. Okay. And then we're going to have a negative x on the top. And then this -1/2, all right, it is under a radical. So that negative, though, we'll just bring that down to the denominator. So let's go ahead and rewrite that as -x over the square root of 25 minus x squared. Okay. Okay, so our formula we're going to use for this is the surface area is equal to 2 pi, and we're going to integrate from a to b of f of x times the square root of 1 plus f prime of x squared dx. Okay, so so we're going to go from -2 to +3. Okay, so let's write that here. So 2 pi integral from -2 to +3. And then what's going to be our f of x here? Okay. So f of x is going to be our y, right? The square root of 25 minus x squared. So that's what we're going to write down. So 25 minus x squared. Okay, and then again, this is still being multiplied by the square root of 1 plus, and we already figure out f prime of x, and that was this sucker right here. Okay, so let's go ahead and put that in. So we're going to have a negative x over the square root of 25 minus x squared. Okay. And then this is all being raised to the second power. And then we have dx. Right. All right, so first let's look at the visual of what's happening here. So what we're trying to do is we're trying to find the surface area generated by revolving this particular function. So if we type in, original function, the square root of 25 minus x squared in our calculator, okay, then we would get something like this, right? However, we just want it from -2 to +3. So if we change our window, okay, so second here. All right, so I changed my x from -2 to +3, then I graph it. All right, so I get something like this. Let me a little bit further out. Okay. All right. So again, we get something like this, but again, we're going from -2 to +3, and we're just going to revolve that. So let me pause this for a second. Okay, so I took a snapshot of the graphing calculator here. So again, this is our graph. This is our um, y is equal to square root of 25 minus x squared. Okay, and then again, what it wants us to do here is the x-axis right here. And it wants us to revolve that around the x-axis, right? So we're going to revolve this around the x-axis. Okay, so we get something like this, right? And our goal is to find the surface area, okay, of this particular shape, okay? Okay, so yeah, so what you want to do here is you want to simplify this part here, right? Let me go back to my color here. Okay, so we have 1 plus, and then the negative x, because this is being squared, the top and the bottom, so that negative will just become a positive. So that's going to give us an x squared. And then the radical there is going to go away because of the square. So we'll just have 25 minus, trying to not write too big here, 25 minus x squared. Okay. All right. Then I'm going to try to combine this together. So what I can do is I can rewrite 1 as 25 minus x squared divided by 25 minus x squared. Okay, plus x squared over 25 minus x squared. Okay. So what happens in the top will be 25 minus x squared plus x squared divided by 25 minus x squared. Because now we have the same common denominator. We can just add the numerators there and leave the denominator the same. So our x squares are going to cancel, okay, leaving us with 25 over 25 minus x squared. Pause here for a second. All right, so let's rewrite this. So I'm going to bring everything down. Okay, so we have 2 pi, the integral from -2 to 3 of 25 minus x squared. And again, this is all under the radical. So that'll be 25 over uh, 25 minus x squared. Okay. All right. So now since both of these are in under the radical, I can combine them together as one big radical. So let's go ahead and do that. So we have the 25 and then times 25 minus x squared times that by 25 divided by 25 minus x squared. Okay, so notice that the 25 minus x squared are just going to cancel. Again, this is my scratch work here. So that leaves us with the square root of 25, which is basically just 5. Okay, so now we have the integral, right? So we have the 2 pi in the front still from -2 to 3. And then all of this now just becomes 5. And of course, don't forget the dx here. Okay, so we have 5 dx. Okay, so now we can integrate this. So this becomes 2 pi 5x, and we're going to go from -2 to +3. Okay, so then I can just evaluate this. All right, so we have 5 times 3 minus 5 times 2. Okay, so I'm going to do that. We get 2 pi times that by 25, which gives us 50 pi. Okay, and then that's our answer there.